Hello friends, very good morning. Myself, Professor M.H. Annaya, and in this video, we are going to work out a problem on the section of a cylinder, which is being cut by a section plane, which is normal to VP, means perpendicular to VP, and inclined to HP, such that the true shape of the section is an ellipse having minor dia 40, major dia 60 millimeter. He has not given us anything about the diameter of the cylinder, and only the height of the cylinder is being given. The cylinder is having a height of 90 mm, 90. Friends, this is a very interesting problem. And see here, when you have a cylinder resting on HP on one of its circular ends, this is seen as a cylinder in the top view, circle in the top view, and as a rectangle of the given height in the front view. But he has not specified in this problem what is the angle made by the section plane. Friends, we will start this concept by assuming this to be cut by a horizontal section plane. Whenever any cylinder or prism is cut by a horizontal section plane, there is a cutting plane which is parallel to the base or to the XY or to HP. In the true shape, you are going to get whatever the shape you have got. If it is a cylinder, you get a circle in the top view. If it is a prism, a square prism, you get a square in the top view. If it is a pentagonal prism, you get a pentagon in the top view. Now friends, instead of this horizontal section plane, if it is cut by a section plane which is perpendicular to VP and slightly making an angle, some angle theta with HP. So the moment it is inclined to HP, then the true shape, whatever you get, is going to be an ellipse. And remember friends, in all the cylinders, whenever it is cut by a section plane inclined to HP, in the true shape, the minor diameter is going to be the diameter of the cylinder. So this is a very important concept, and it will help you to know more about the section plane, etc. Now friends, I have written the top and front views of the cylinder. So here I just explained, whenever the cylinder is cut by a section plane which is normal to VP and inclined to HP, the minor diameter will represent the diameter of the cylinder. So based on this concept, I have written a circle here in the top view having diameter equal to 40 millimeter. So in the same problem, if the ellipse you are getting is 50 millimeter minor dia, then the circle diameter is going to be 50 and so on. So without knowing this fundamental concept on the section of solids, you cannot work out this problem at all. Now friends, what are the things that is being asked here? We have been asked to determine what should be the diameter of the cylinder. You know very well now with the explanation I have given, the diameter of the cylinder is going to be 15 that is a 40 millimeter, that's the minor dia. So I'll write down here the dia of cylinder in this question is equal to minor axis or length of minor axis, that is equal to 40 millimeter. So this is the answer for the first part of the question, determine the diameter of the cylinder. Then inclination of the section plane, we will see how it works out. Friends, when this is being, say it is passing through the mid height of the section plane. Suppose you have got a section plane like this friends. The point where it is cutting these loss generators or end generators. So you can take the center of the cylinder at the center with half of this at the radius, that is 30 mm. You can just cut an arc here, another arc here. So friends, I am going to draw two arcs with radius is equal to how much? 30 millimeter. So this is 30 and this is 30. So in the mirror image, that is the true shape of the section, you are going to have the major diameter of the ellipse as 60. That is equal to this value. Now friends, this is the section plane we have got, and I will call this section plane as SS, and it is passing through the say mid height of the cylinder at a height of 45 millimeter from here. And friends, now the portion that is retained here will mark like this. Will show by visible lines. This is the portion of this cylinder. Now, before going ahead, let me mark these ends of the cylinder generators as AA1, BB1, CC1, DD1, EE1, FF1, GG1, and finally HH1. This is O comma O1. This is O dash. The center of the top face. O1 dash is the center of the bottom face. And this is the part that is retained after this is being thrown out. Now we have answered the first part of the question. Inclination of the section plane. Friends, after you cut this with radius equal to 30 mm, that is half of the radius of the major axis, 30 mm. Another arc here with the same radius. We have got this line. So if you measure this angle, the angle made by SS with the XY will give you theta. That is, the inclination of the section plane with the HB can be found out. And finally friends, draw the TS, true shape of the section. So friends, to draw the true shape of section, and also we can say sectional top view, will have both. So we'll have the sectional top view and true shape. Friends, whenever any of these prisms and cylinders are cut by section plane between the top and bottom ends of that solid, whether it is a cylinder or a prism, irrespective of the orientation of the edges in case of prisms or the cylinder, what happens? If it is cut anywhere between this end to this end, anywhere in between, either by horizontal section plane or by section plane inclined at any angle between these two limits, the whole or the complete top view of this solid is to be shown hatched. So, if it is a circle or cylinder, we are going to hatch or section the complete top view by lines inclined at 45 degrees to the horizontal. This is the top view with the section. So we'll call it as STV. STV means sectional top view. And this is the front view. We will mark it as FV. Is the front view. And now friends, we are required to find out how to draw the true shape of the section. Now, we will draw a plane or a line parallel to the section plane SS and obtain the true shape of the section. Friends, anywhere outside this, I am going to draw a line parallel to this, parallel to the line SS at any convenient distance. And friends, let us see which are all the points where the object is being cut. Here friend, this is A dash, A1 dash. Last one is E dash, E1 dash. Center is C and G. C dash, G dash, C1 dash, G1 dash. All the 8 generators of the cylinder are cut by this section plane. So you will have a point on a point on BB, point on CC, DD, EE, FF, GG and HH. These are all the points on the generators in the top view. Friends, after marking all this, let us number them as 1, 2, 3, 4. On A1, this is 2, 3, 4, 5, 6, 7, and this is 8. Since there are 8 generators, you are going to have 8 points. Let us transfer all these points to the generators. So this is 1, 2, 3, 4, 5, 6 will be behind that. This is 7 and this is 8. This is how you mark this. And let me show all these points where the section plane is cutting the generators. Friends, now from all these points 1, 2, 3, 4, etc., let us draw lines perpendicular to these SS or perpendicular to this line, say x1, y1. Some reference line parallel to this. So friends, I will mark them here. From 1, I will draw a line perpendicular to that. A line like this. A line through the last. Then lines through all this you should draw. Friends, you will turn all these lines parallel to or perpendicular to this line. 1, this is 2, line here, center 1, line from here, line from here. Remember friends, this gap and this will be same, these two gaps will be same. So these are all the points where we have to mark these points 1, 2, 3, 4. So 1 is here, I told you. Friends, how to obtain the true shape? Now, if you observe the top view, point 1 is here at a distance of so much. So on this line which is drawn perpendicular here, I am going to mark that point. So this is point number 1. Then on this you have got BB and HH. On BB it is 2 and 8. So friends, you are going to have 2 and 8. And then you have got 3 and 7. 3, 7. Next we have got 6, 4. 6, it will be exactly on this. And 4 here on this. 6, 4. Finally, you are going to have this point. And we can just number them again here. This is 1. 8 is closer to this. So 8 means this is 2.3, 4, 5 is this extreme end. Then 6, 7 and 8. Friends, after obtaining all these points on these lines which are drawn perpendicular to section plane, we will draw a smooth continuous curve passing through all these 8 points. And we have to hatch it or section it by lines drawn at 45 degrees to the horizontal. Friends, if you just observe this is the true shape of this section, and it is, you know very well, it is an ellipse with major diameter is equal to this length, that is 1 to 5, 1, 5. This is a major dia. That major dia is same as this 1 to 5. This 1 to 5 are the same. And the minor dia, if you observe friends, so this is the minor dia. 3 is here at a distance of so much. 7 is here. So this is the distance between 3 and 7 is nothing but the diameter of the cylinder. So this is the concept on which we have worked out this. So this is 40, the diameter of this cylinder is 40. So this is 40. Minor axis is 40 mm and the major axis, this is 30 plus 30, 60. The minor axis has got a dimension of 60 millimeter. This is the true shape of the cut section or true shape of the section, and it is an ellipse. So whenever any cylinders resting on one of their ends on HP and it is cut by a section plane, a vertical section plane which is normal to VP, a section plane which is normal to VP and inclined to HP. Anywhere it is cut between the top and bottom faces, including the highest top points here, highest point here and the highest point here. The true shape you get is going to be an ellipse, and also the minor axis of the ellipse is going to have a dimension equal to the diameter of the cylinder always, and the major axis depends on the inclination or the orientation of the section plane with the HP. Friends, please go through the complete video without fail, and if you are happy with the presentation I have made on this problem, which is a very important problem, very often asked in the examination and this chapter sections of solids. And if you are happy with the presentation I have made, please share the information about my channel and my videos to all your friends. Thank you very much for watching my YouTube video. Have a blessed day.